So, hello and welcome back to my C++ tutorial playlist. In this video, we will take a short look at lambdas, and we will first take a look at an introduction into lambda functions, and then we will take a look at some example codes that I will code up live. But first of all, what are lambdas in general? And lambdas are just unnamed function objects that can capture variables. This is a very simple lambda function. As an example, we can see here it captures variable from the surrounding scope by value, and then it returns double that value. Yeah, that is just a very simple example, but it basically works like a function. We can see we don't have parameters here, but the x gets captured still from the outside here, and we can just call it here, and we will take a look at how this works in the example code. Here's a short list of how you can capture variables. You can capture x, the variable x from the surrounding scope by value by just writing x. You can use this AND sign here to capture it by reference. You can also create a new variable called x and initialize it with 0, basically how the initialization in a for loop works in the beginning, and then capture it. And you can also capture the entire surrounding scope by value. Really important here is to note for this too, you can capture the surrounding scope by value or by reference, but only what you really use will be actually captured. And that basically happens at compile time. It checks what you use from the surrounding scope and only uses what you actually reference inside of the lambda body. And this captures the current object. For example, you could in a method write this, and then you have an access to this pointer basically. And now let's take a look at some practical examples. So now let's take a look at some practical examples. Write a simple hello world to check if everything works. And then we can run it, and to the surprise of no one, this prints hello world. Now let's take a look at some simple lambda functions. The example we had on the slides is this, and we capture x by value, and now we have a lambda like that, and we can return something here, and then we can print out value x is whatever we provide here. And then we can just say, and when we run that, we can see x is now 6. That also surprises no one. What's interesting is to see what happens if we change x here before we call the double x, and it's still 6. Because it got captured here and it wasn't a parameter. So let's see how it happens when we have a parameter here. Now you can guess what happens now. And as you can see, it's 8 now because we don't capture the value here. We provide the value as an argument here. So that's basically also the difference between a capture and a parameter. But what's also interesting, probably something like this. Now you can see we don't have a type here anymore, but we have an auto here. So this works now for different kinds of values. And this is behaves like a template basically. Whenever we call this lambda with a specific type, then the lambda of that type gets created and basically inlined there. So this really behaves like a template, like templates. Then, of course, you've seen we can capture by value, but we can also, of course, capture by reference. Just as an example, I will capture the entire scope, and now we can use all the variables from the surrounding scope. we can still maybe return x, and we also have access to y, so let's double that also. So run that. And as we can see, we've doubled both values, even though we only returned the value of x, but we captured both by reference, so we modified the surrounding scope. And if we capture by value, then you can see here, we can't assign to it. As you have seen, we had access to all the values here, but this is named double x, and sometimes, or most of the time, we want to make sure that we don't modify the surrounding scope. So, of course, we can specify which value we want to capture, and that is only x. And as you can see here, we get an error here. And if we try to run it, then we need to capture y by reference, of course. As we've seen, we prevent our program from having artifacts that we don't want. Now, what are lambdas often used for? And these are callbacks. To demonstrate that, I will include functional. And let's have a function here called called call for callback, and this takes in const std, and then we can specify a callback lambda object that we want to basically call for us. And this is often used in asynchronous programming when we want to do a lot of stuff, and as a result of this completing, we would want to call the callback here. And we can take a look at how that works here. So we create a lambda, and of course we can capture whatever we want also here. And this needs to be auto. And in here we can just do whatever we want. For now we will just print something like that. And then we can make use of our callback, and then we provide our callback function like so. And as you can see, this will get passed in here and then will be called by our callback function. So let's run that. And as we can see, this was a little bit pointless, but you can see the job was completed. We can do some more interesting stuff here. For example, we can take in a result and then do calculations, for example, do stuff that are very intense, computing intensive, for example. And that is something I always wondered about. I think we only need to specify int here, no name. And yeah, let's see what the result of that is. Job completed, of course. We need to actually job completed. Result was that. And yeah, this is basically how callbacks work. It's nothing difficult, but it's very useful because we sometimes don't know when something completes, and we can easily wrap this into, for example, a thread, and that goes off, and we can move on with other stuff, and it will then just call the callback whenever it's done. And what we need to do here is to specify the arguments, so the callback, after have our callable. So let's run that. And it still works, but now it works asynchronously, and we can do more stuff here. And then this can work in parallel, and here we join again. And I think we should be able to use JThreads here also, and they join automatically. And yes, we can use JThreads here also. These are more convenient, and I would also prefer to use that. They are also exception safe. Like unique pointers, we can make sure that they get always joined, even when an exception in our do more stuff happens. So that's a really good thing to use. And I think that was already everything I wanted to show you in this video. Was a little bit unstructured and was a little bit short, but yeah, so much for that. And with that, we can move on to asynchronous programming very soon. I think there are 1 or 2 videos I want to cover first, but yeah, see you.